All right, here we go, 1A. Most of you probably already have this done, so you don't have to pay attention. You can go ahead and do whatever it is you want to do. But if this confuses you, here we go. So, first of all, always in the back of my mind, I know this is my exponential. Now, that's an exponential, but it is an increasing exponential. That's like y equals 2 to the x. This one is not increasing. This one is decreasing. So it has the same shape, it just looks like this. Same asymptote, same y-intercept, going in the opposite direction. Now I'm going to take that picture, that's this. I'm going to take that and drop it down 1. Everything. So the asymptote comes down to -1. The intercept comes down to the origin. And I just sketch it in. I overthought that a lot. So my end behavior. And I am going to start taking off if we're not using the right notation, people. This is the notation we use for end behavior. The limit as x approaches infinity of our function. The limit as x approaches negative infinity of our function. So here we go. If we're looking to see what happens as x approaches infinity, that means we're going that way. That's where infinity is, right? What's happening to the red curve? That's when I graph the red one. What's happening as I head toward infinity? It's going down toward -1 from the top, right? It's approaching -1 from the top. Now what's it doing in the other direction? As I go left, what is my red curve doing? Infinity. There's your infinity.
How come you don't have to say which way it's going with the infinity? Like you use the plus with the 1.
Positive, this is positive infinity.
Yeah.
And positive infinity is just going up. Yeah, there's no like directional thing here. It's just going up. All right. Anybody else find something before you just start working on your own?
You do 2A on the calculator side?
2A on the calculator side. All right, we did some of these. And they're all pretty much done exactly the same way. So how did we start this when we did it before? Multiply by 2, get rid of the fraction. And don't even act stunned. People, that's what we do. We get rid of fractions. Now what issue do we have? A negative exponent. So Lana, what am I going to do?
Change it to like 1 over EX.
So far, I've not done anything except standard procedure. This is what we do. Now look, I have another fraction, don't I? So I'm going to get rid of that fraction. So what will I multiply by this time? E to the x. So I'm going to multiply everything by e to the x. Now why did we do that? So that that's gone, right? So what's this? You gotta have your thinking cap on. What's something times itself always? The thing squared. So this is e to the x squared. I'm going to go ahead and subtract the 15 e to the x minus 1. Everybody follow all that? Isn't this the same as n squared minus 15n minus 1? these guys are always gonna come out in quadratic form. So you just have to recognize that. Now, if you're lucky, this factors. Well, we're not lucky. So what do? Quadratic formula. So n equals negative b plus or minus the square root of b squared minus 4ac all over b. So I'm going to end up with n equal to 15 plus or minus the square root of 229. Would you agree with that? Okay, now remember, I mean, that would be great if our job was to solve for n, but our job wasn't to solve for n, our job was to solve for x. So, e to the x, that's n, e to the x equals 15 plus the square root of 229 over 2, or e to the x equals 15 minus the square root of 229 over 2. Now, this one right here isn't solvable. Can somebody tell me how I know? Is that solvable, Seth?
Negative.
This is a negative number. This is a negative number. The square root of 15 is 225. So when I subtract that, it's going to be negative. Can you raise e to a power and get a negative? No. You can't raise a positive number to a power and get a negative. It doesn't happen. Now this one's doable though, so what am I going to have to do to solve this? ln. So x equals your answer, your final answer is going to be the natural log of 15 plus root 229 over 2. So whatever that is, I got 2.712. Anybody else get that? Perfect. Got it? GTQ, guaranteed test question. All right, anybody else find anything before I set you loose on your own?
C to C.
He had his hand up. Dylan? Which one?
3H.
On the no calculator, 3H. Okay, this one you have to have your thinking cap on. Would be really easy if it weren't for this 2 right here. That 2 is messing everything up. David?
You gotta make it into like an ln.
Exactly. So what ln what would be 2? ln what would equal 2? Oh, guys, you need to know this. ln e squared. Yep. This is ln e squared. Right? ln e cancels, that's 2. So that's 2. What's this? This is ln 8. Remember, coefficients are exponents in logarithm land. Now, these 2 logarithms, do not drop the logarithms. You cannot drop them unless you have one on each, just one on each side, okay? So, I'm gonna combine those two. They are an addition, so they will combine as a multiplication. You with me? Now I can drop them. So 4x minus 2 equals 80 squared. I am solving for x. I know you think you have two variables here, but you don't. E is a constant. You're getting x by itself. So 4x equals 2 plus 8e to the second. So x equals 2 plus 8e to the second over 4, which actually reduces to 1 plus 4e squared over 2. I don't know if I did that on the answer key or not, I can't remember. Okay, Dylan, got it? Okay, all right.
Can you make the answer 2e plus 1/2?
Yeah, 2e squared?
Yeah.
Yes, plus 1/2, yeah, you can split that fraction if you choose, yeah. All right, Alana, what was your question?
That kind of like answered my question.
Huh?
That answered my question.
Okay, good. Good, Mallory?
Can you use 3F on the no calc?
3f. Okay, this is an exponential equation. The variable is an exponent. Guys, when you are solving for an exponent, you have two choices. You can use logarithms, but not on the no calculator part, right? So what are we gonna have to do? David?
Make a common base.
Exactly. You guys, if this is a no calculator problem, it will be rigged so that you can get a common base, because that's the only way to do it. Okay? So what, look at the numbers. 9, 27, 81. What base am I gonna use? 3. So 1/9 is 3 to the negative second. 27 is 3 cubed. But it's also the 2x minus 1. 81 is 3 to the 4th. So this will be 3 to the 4/3. Remember, radicals are fractions, exponents, fractional exponents. Now, let's not get confused here. We know what to do. Okay? If you had a squared times a cubed to the 5th, what would be the first thing you would do in that problem? Multiply these. So we're going to have 3 to the negative second, and then 3 to the 6x minus 3. Now, once this became a squared times a to the 15th, what would you do with those exponents? Add them. So I'm going to add these. So I'm going to have 3 to the 6x minus 5 equals 3 to the 4/3. Now, 6x minus 5 equals 4/3. Everybody okay with that? You can either deal with the fraction, it's completely up to you. It's been a long day. I think I'll multiply by 3. So 18x minus 15 equals 4. 18x equals 19. X equals 19. 18. That's going to be the answer you get, no matter how you choose to do the problem. All right, is that it? Lane?
Could you M on the backside? The calculator.
M. I plan to save $150 a month. Okay, so what formula am I going to need? I'm going to need my future value formula, which I need to find. All right, so here's my future value formula. Remember, I gave you this. All right, there it is. So here we go. Problem says, I plan to save $150 a month, so my payment is $150 a month. The interest rate is 0.0175 divided by 12. I'm doing it monthly. Doing it for 18 years. So how many payments am I making? 216. Okay, so Lane, you have any question about that? Putting the numbers in the formula. Okay, then it's just a matter of typing it in carefully. Remembering that when you divide by this guy, make sure he's in parentheses. Actually, it's not as much as I hoped. I got 38,051 and 48 cents. What?
I got the same thing.
Yay, raw. Okay, you good? Alana?
Can you do I, please?
On that same page?
Yeah.
Okay, now I need another formula. Okay, last one, and then you're on your own to review. Here we go.
This formula that we use for this one is one that you'll give us, right?
Yep. I give you present value, future value, and Newton's law of cooling. So this one, this problem is going to involve Newton's law of cooling. You can leave that open, I closed it because someone was making noise out there. But you can leave it open. Now, what I'm not gonna do, gang, is tell you what to put where. Okay, I'm gonna give you this, literally, this is what you're getting. So when you read, which one am I doing? I. You have to know what goes where. So it has cooled from 98 degrees to 62 degrees after 12 minutes in a room that's 22 degrees. Okay, stop right there. Build your equation from that sentence. Okay? So what goes where? Where's the 98 go? That's the beginning temperature. Remember, T sub naught, T sub 0, T sub naught represents the initial temperature. So that's 98. Okay? Where do I put 62? That, oh no, that's not T sub m. That's the temperature after a certain time. So we're gonna put 62 here. What does the T sub M stand for? The temperature of the medium, which is the environment. So that's gonna be 22, and also here. And the time is 12 minutes. Now, look at that equation, make sure that makes sense to you. Because if you don't know where to put the numbers, you are up the creek without the paddle, as they say. Alright? This is not gonna give us the answer, but it is gonna give us our K value. So here we go, 62 equals 22 plus 76 e to the negative 12k. So how do I go about solving this? Subtract the 22. Divide by the 76. I wouldn't mess with reducing it because you're just gonna go to the calculator anyway, right? Next step, natural log both sides. So the natural log of 40 over 76 equals negative 12k. Everybody on board? So k is gonna be the natural log of 40 over 76 divided by negative 12. Now, I can go ahead and put that in my calculator, but I'm not gonna round it off, just save it. Okay? Now what? Aiden? Make a new same formula, new equation, what's it gonna be? 40 equals, that's my new temperature, right? Now, is this gonna change? Nope. Is this gonna change? Is the original temperature still 98? Is the medium still 22? So that's gonna stay, what was that, 76? Does that make sense to everybody? Make sure it does, Hank, you got it? So we'll subtract the 22. Divide by the 76. I know we have two variables here, but don't worry, we have that one in our calculator, right? So we don't need to worry about it. So we'll ln both sides. So ln 1876 equals negative kt. So how am I gonna get t on my calculator? I'm gonna do ln 1876 and divide it by negative the number in my calculator right now. Let's see what I come up with. Okay. I lost the number. Alright, now I got my key back again. Okay. ln. I got 26.929. Anybody else get that? And what would be the unit on that? Is that degrees or what?
Minutes.
That's minutes. How long will it take? So it'd be that, about 27 minutes, basically. David?
How do you like keep the number of K in your calculator?
Well, okay, type K in.
Yeah.
You got it in?
Mm-hmm.
Just the last thing on there?
Yeah.
Okay, now, type in ln 18 divided by 76, close the parentheses, divided by negative second answer.
Oh.
Now, if you have a newer calculator, you can drop down and click on it and it drops it in. If you have an old calculator, you have to use the second answer.